Hello. As with many processes, and especially in case of biological processes, there is a lot of terminology that is associated. And it will be wise for us to get through them before we proceed further into transcription. Welcome. The double-stranded DNA should be transcribed to form RNA, and that RNA should be translated to give rise to a protein. Here is an example of a double-stranded DNA, and we have the formation of RNA upon transcription, and this mRNA would give rise to a protein. So out of these two strands, and there are ways of how we call them, because in that particular context about that gene, we have to be able to distinguish from top strand to bottom strand. It's always not good to say top strand and bottom strand. We should be able to, at least in that context, in that locus, for that particular gene, we should have some terminology that is associated. So here is ATG, which is the start codon, and it is followed by second codon, third codon, and fourth and fifth, and then we have a stop codon. So that is an open reading frame. We have a start codon followed by continuous codons and ends with a stop codon. So the open reading frame is present on the top strand in this case. And so RNA polymerase has to read and make a copy of RNA, complementary copy of RNA, which should have the codons in the same way so that the ribosome can read them and make the protein as given here. So if we saw the chemistry of the RNA polymerization, a template is there, and to that one base is added at a time, and the complementary to the base that is present in the template is added. So in this case, which one should be the template is the question. Should the top one be the template, or should the bottom one be the template? If we take the template for transcription as the top strand, we would actually get something, a sequence similar to, say, RNA sequence, A, U, C, G, T, C, etc. We are not getting the codon, the open reading frame as it must be. Instead, if we were to transcribe using the template, the bottom strand, then we would get GACU and then AUG, CAG, etc. So we are able to produce mRNA, which is having the codons in the readable form as it must be for producing this particular protein. So the bottom strand is going to be the template when it comes to transcription, and the top strand, although it is having the complementary of what we want as an open reading frame, it is the non-template strand. And another way or the way I try to remember is there are other things about coding, plus, and sense, which will come, if not in transcription, many other cases. The coding one is for me, the mRNA is the coding strand in a way. Coding in the sense because it will give rise to the protein that the gene is intended for. So I call the mRNA coding. I call it as the plus strand, and I call it as also this sense strand, because that is what is giving the sense of the protein or making the protein of the interest or intended. So in that way, if I remember mRNA to be coding, plus, and sense, then whichever is similar in the DNA here, whichever strand is similar to that of mRNA would also be coding, plus, and sense. So because it has the codons as such, it is not of use for transcription, or it's not used for translation either, because the template strand, the bottom strand, is the one that is giving rise to mRNA, which is read by the ribosome to produce a protein. So the bottom strand in this case is the template, It is the non-coding one because it doesn't seem like having any codons, but upon transcription we get a complementary strand which has the codon. And because it is reverse, or it is complementary to the actual open reading frame, we call it as minus and antisense as well. At least for the sake of in the light of transcription, we should be able to know what is a template and what is a non-template in the DNA. The strand that is going to be, which is going to be read by the RNA polymerase and polymerize a complementary RNA strand, is the template strand. In this case, it is the bottom one. I hope you can remember them. See you later on. Thank you.